Hello friends, welcome to Physics Platter. Today in Physics Platter I will introduce to you the spherical mirrors. So basically we will talk about the definition of a spherical mirror and the terms involved with a spherical mirror. So first of all, let's talk about what a spherical mirror is. So basically a spherical mirror is nothing but a mirror made out of a part of a sphere. So if we take a small part out of a sphere and make a mirror out of it, then that's called a spherical mirror. Okay, now because the curvature that we took out has two surfaces, we can make any of the surfaces reflecting. All right, for example, we can make the inner surface of the curvature reflecting, or we can make the outer surface of the curvature reflecting. If the inner surface of the curvature is reflecting surface, then it's called a concave mirror. Otherwise, if the outer surface of the curvature is reflecting, that's called a convex mirror. So basically there are two types of spherical mirrors, concave and convex. If the inner surface of the curvature is a reflecting surface, then it's called the concave mirror, whereas if the outer surface of the curvature is reflecting, then it's called a convex mirror. Okay, let's write down the terms involved with a spherical mirror. Then we will define them one by one. So what are the terms involved with a spherical mirror? First of all, number one is pole. Number two is the center of curvature. Number three is focus of the mirror, or the focal point of the mirror. Number four, the principal axis. The principal axis of the mirror. And then the number five is the aperture of the mirror. Aperture of the mirror. The pole is represented as P. The center of curvature is represented as C. The focus or the focal point is represented as OF. Principal axis, which is a straight line, we will see, and then the aperture is another length of a straight line. Okay, let's draw a concave mirror. Okay, so this is our mirror whose inner surface is reflecting. That means the reflecting surface of the curvature is the inner surface of the curvature. Now, the center or the midpoint of this reflecting surface is termed as the pole of the mirror. I say it again, the center or the midpoint of the reflecting surface of the mirror is called the pole of the mirror. All right. Now, because it's a part of a sphere, that sphere must have a center. Let's say somewhere here, which is denoted as C. So this center is called the center of the sphere, or the center of the curvature. The center of the curvature. Okay, C. Now, if we join P and C by a straight line, then this straight line is called the principal axis. Principal axis. Okay, which goes to the center of the mirror and center of the curvature, or the pole and the C, pole P and the C. And exactly the midpoint between P and C, exactly the point in between P and C is called the focal point, which is denoted as F, which is defined as the point where all the paraxial beam after getting reflected from the mirror converges to. Okay. What is a paraxial beam, by the way? Paraxial beam is nothing but the beam or the ray which is parallel to the principal axis. So this is my paraxial beam and they must go through the focus like this and like this. Okay. Okay, so pole, focal point, center of curvature, principal axis. Now we are left with the aperture. Let's say the upper end of the mirror is M and the lower point of the mirror is M prime. Then this part of the reflecting surface which is exposed to the light, or which is active to reflect the light, is called the aperture, or the active area of the mirror. And this length from the top point to the bottom point, mm prime, is called the aperture of the mirror. Okay, here PC is the radius of curvature, which is also the radius of the sphere, which is represented as R. PF equals to, of course, FC equals to, represented as, is termed as the focal length F. The focal length F. That means from the picture, as I told you, F is exactly the middle point between P and C. We can say PF equals to PC by 2. That means F equals to R by 2. Okay. So let's draw the same picture, same terms in case of the convex mirror. Okay. So we will draw a convex mirror here whose, let's draw it here. That's a convex mirror whose reflecting surface is the outer surface of the curvature. Again, the pole will be the center of the reflecting surface. The center of curvature will be the center of the sphere CP. This time, see, the reflecting surface is the outer surface of the curvature. That means the center of curvature must be in the opposite side of the reflecting surface. Okay. So if we join P and C, then by a straight line, then that forms the principal axis. Principal axis of the mirror. Again, the midpoint between P and C is F, which is the focal point, and then M prime is the aperture, PC is the radius of curvature, just like the concave mirror. So this is concave and this is convex. This is convex. Okay. So the difference in concave and convex is just geometrically looking at the picture in difference in the terms is that the focal point and the center in case of convex mirror lie in the opposite side of the reflecting surface, whereas in case of the concave mirror the focal point, the center of curvature, lie in the same side as the reflecting surface. Okay, that's all for today, and then actually I'll finish it off with one small point, that as we all know, the plane mirror, right? Now, as we all know that a plane is a part of a huge sphere, right? A plane is a part of a huge sphere. That means a plane mirror can also be considered as a spherical mirror of radius infinite. That means the midpoint will be P and the radius C will be at the infinite distance from P. That means the radius of curvature R equals to infinity for a plane mirror. Okay, so a plane mirror, just to finish it off, a plane mirror is also can also be termed as a spherical mirror of radius of curvature infinite, or the focal length also infinite. Okay, so that's all for today. I will see you in the next video. If you like this video, please give it a thumbs up and share it with your friends. Subscribe to my channel so that you don't miss my videos. Okay, if you have any suggestion, queries or questions, please write down in the comment section. I will try to answer all your queries in my next video. Okay, thanks for watching the video. Take care.